Yesterday we looked at this, identifying the sides of the triangle and setting up sine, cosine, and tangent. Okay? We learned our magic phrase, SOHCAHTOA, which helps us identify remember, the functions are not SOHCA and TOA. The signs are sine, cosine, and tangent. That's what the S, C, and T stand for. The O, A, and H stand for opposite, adjacent, hypotenuse. SOHCA, TOA is an acronym to help us remember what goes with what. And it's going to be really key to helping us understand how to set up and solve these problems that we're going to do today. So, again, our favorite SOHCA, TOA, right there, that's what's going to be key for everything that we're doing today. One thing you probably noticed yesterday as you were doing your homework is that several problems, when you changed them from ratios to decimals, you wound up with the same decimal all the time, over and over again. And that should be an indication to you that the value of sine and cosine and tangent, while we can get it from the lengths of the sides, isn't really dependent on that. It's really based on the angle. So all those sine, cosine, tangent, all those triangles that had the same value for tangent of whatever it is, that means all those angles were exactly the same angle in those right triangles. So the value of sine, cosine, and tangent is more dependent on the value of the measure of the angle than on the length of the sides. The sides are just a way to find that value. But it really correlates more closely with the length or the measure of the angle. Okay? So cutting ahead to what we're doing today, and some of these notes are already filled out, some of these are repeats because it's important to have the repetition. Okay? But I got some fill in the blank here today. If triangles are similar, they have the same. First blank you fill in, same value for sine, cosine, and tangent. Which implies that for any given angle measure n, the value of sine of n is a constant. Your second blank. This means, third sentence, that the value of sine and cosine or tangent, the value of any of those functions, could be expressed as either a ratio or a decimal. Our calculators are going to help with this right now. Now we're going to take a little deeper look at our calculator. So get your calculator out. If your calculator is one of my calculators, grab one of my calculators. If you don't have your own calculator, you really, really, really need to get one. Okay. Now, the first thing we want to do is we want to make sure our calculator is in the correct mode, because there are many ways to measure angles. Just like you can measure temperature in degrees Fahrenheit or degrees Celsius, you can measure volume in quarts or liters, you can measure angles in degrees or radians or gradients. There are three different types of angle measurement systems. We only use degrees in geometry, so you want to make sure you're in degree mode. So in your calculator screen, there should be a little D or a DEG or something like that. If you have one of the 84s, you have to go into your mode, and the third line down will say radian or degree. Degree should be highlighted in black. If it's not, arrow over and hit enter, so it is, to make sure you're in degree mode. If you're in the wrong angle measuring mode, you will get all of your answers wrong, because we're measuring angles in degrees, and if your calculator thinks you're measuring them in a different measurement system, it will give you completely wrong answers. So is anybody not able to determine if they're in degrees or not? Or need help figuring it out, or if you need to change, need help figuring out how to change? You want, yeah, that's rad. You want to be in deg. There you go. There you go. You're good. So, you're in degrees. You're good. Deg, yep. Deg for degrees. Question? Oh, okay. Everyone good? We got degrees. To check that, what I want you to do is I want you to find the value of sine 70. So literally, I want you to push the sine button, 70, enter. Now, a couple of you have the older TI calculators, so you have to push 70 sine. I've seen a couple of people with older TI calculators. Yep. You should get 0.9397. Okay? And some people go, well, no, I got 9396. Well, if we round it up, because we always round to the fourth decimal point, we did that yesterday, we always round to 4, so that last digit after that second 6 is a 9, so that 6 goes up to a 7, right? So if you got something other than 0.9397, please raise your hand so I can come around and help you figure out what went wrong so you can get it right, so your calculator is working, and you are working your calculator in a way that you can do things. Careful. Okay? So, now the question I ask you, is that value that you got for sine of 70 in any way dependent on the length of the sides of a triangle? No, I don't even have a triangle drawn, do I? There's no triangle present. That's just the value of sine 70. That means for every right triangle, if I take the ratio of the opposite over the hypotenuse with a 70-degree angle as my perspective, that ratio will always reduce to 0.9397. So if I have a right triangle with a 70-degree angle and that's my perspective, the ratio of opposite over hypotenuse, sine, always is 0.9397. That's what's going on. Okay? So we just got that sine 70 is 0.9397. Okay? This is an example, yep. But from our ratios, the sine of 70 is what ratio in terms of words? So, okay? So in terms of ratios, sine of 70 is what ratio in words? Sine is, no, not so. I mean, so is the acronym we're going to use, but that stands for sine is opposite over hypotenuse. Okay? So sine of 70 is 0.9397, but the sine of 70 is also the ratio of the opposite over hypotenuse. Since both of those things equal each other, by substitution, therefore, the 0.9397 is the ratio of the opposite over the hypotenuse. Right? That's something we've done a lot of substitution property over the years. We know how to do that. Now, what if I know that my hypotenuse in this, so now I've got a triangle, and what if we know the hypotenuse is 21 centimeters long? I know that side's the hypotenuse, it's across. 70 here, the angle becomes my perspective. Which side is the opposite? Is it the left or the bottom? The left. So I'm going to call that X. Okay? The adjacent is down here. It's not involved right now. So we could substitute into this little equation 0.9397, the sine of 70 equals the opposite over the hypotenuse. Can I now solve for x? Algebra-wise, can I do my algebra now? What do? Times both sides by 21, yeah. Okay. Am I multiplying the 70 by 21? No. I'm multiplying the value of sine 70 by 21. Not the angle measure itself doesn't get multiplied, but the value of sine 70 in this case. Why was it sine? Because it's opposite and hypotenuse. And because we kind of set it up that way. Okay? And if I do that, what do I get for x? 19 to the nearest tenth, 19.7. Nearest tenth would be 1 spot. Okay? So that side is 19.7. We just found the unknown side of a triangle using trig. Okay? We just use trigonometry to solve the unknown side of a triangle. That's essentially the one thing we're going to be doing today. Is using trig to find the unknown side of a triangle. Okay? We're going to practice this a little bit. So, when we get problems like this, we're going to go so, ka, toa on the top of our page. Because that's going to tell us almost everything we're going to need to know as to how to set up our equations. Because what we're going to be doing up now is, big surprise, we learned a concept, we're now going to set up and solve equations. We've been doing this all year long, right? It's what we do. Okay? In this picture, it says find AC. So AC is this side here. I'm going to make that my x. Okay? Now, how do we set up and solve these equations? Well, we start with perspective like we did yesterday. Same way we started yesterday. Start with perspective. My perspective is going to be whatever angle we're given to work with. By the way, we can assume that triangles are right triangles here because they look like right triangles for this unit right now. Normally we wouldn't, but we'll just go ahead. Okay? But the angle that's given is my 47. So this 47 becomes my perspective. That's where I am. Okay? So the first question everyone you have to ask is, what's my perspective? Once we've got that down, now we want to identify our sides, just like yesterday. 47 is here, so which side is the opposite? Okay, so this is my opposite. My hypotenuse is over here, so this is my adjacent. Okay? Now the hypotenuse isn't even involved here at all, is it? We aren't involving the hypotenuse in this problem at all. So now the next question becomes, what do I pick? Do I work with sine, cosine, or tangent? I have to know which function to work with. I've got three tools here. You know, the sine tool, the cosine tool, the tangent tool. I have to pick the right tool for the job. That tool choice is based on the sides that we're working with. I'm working with the opposite and the adjacent, and not the hypotenuse. Which one of my tools works with opposite and adjacent? Tangent. Okay? No hypotenuse means no sine and no cosine, because the hypotenuse is involved there. Okay? So tangent is the function I'm going to pick. Tangent never makes sense without a perspective. So we always have to give the perspective of an angle. Which angle are we talking about here? The 47, yes. So tangent of 47, because I need an angle. I can't just write tangent equals. It has to be tangent of an angle. That angle can either be a variable if we don't know it, or a number if we do, preferably a number. Okay? What does that equal as a ratio? Well, TOA helps me remember what that is. Opposite, okay, opposite is x. Hypotenuse is 13. Now, I could turn tangent 47 into decimal, and then solve it. But it really isn't necessary to turn it into a decimal because we know it's a decimal. So what I'm really going to do is I'm just going to multiply both sides by 13. Now, here's where we need to be careful. If you put in your calculator tangent of 47 times 13, your calculator is going to do tangent of 47 times 13. We don't want to multiply the angle by 13. We know that tangent 47 is a decimal value. We've established that already, right? So we don't want to do this. We want to do 13 times tangent 47 in our calculator. And what do we get? 13.9. Last thing we asked, does that make sense? Yeah, it's pretty close. If this angle is 47, this angle has to be 43, because they have to add up to 180, right? And so this side should be shorter than this side because bigger angle, bigger side, triangle inequality. Yeah, it makes sense. We've just solved for an unknown side. We've set up and solved for an unknown side. Now, the interesting thing is when you take the ACT or other standardized tests, they actually wouldn't want 13.9 as an answer. This would be a multiple choice. And your answer would be x equals 13 tan 47. Okay, that's how they're going to show you your answers, which is why it's so important, and I want to see in your homework tonight, setup of your equation. Absolutely have to have this, not just the numerical answer for the length of the side. I absolutely need to see the equation setup, because that's how you're going to be tested on when the time comes. In fact, I think on the chapter test, there's some multiple choice questions where the answers are in this format. Just the way they do on the ACT and the Aspire testing. So it's based on the equation. If your calculator isn't great or isn't working, if you only have a 4-function calculator, the ACT is actually set up to work without a scientific calculator. You don't have to have one to figure it out because you don't need to calculate that value. But we are going to be solving it here. All right, let's look at another example. Same triangle, but now I want to know AB. So my perspective is still down here. My sides are still the same. This is the hypotenuse, this is the opposite, and this is the adjacent. All right? SOHCAHTOA still is in play. Which sides are involved this time? Okay, hypotenuse and adjacent. Which function, which tool uses adjacent hypotenuse? Cosine. CAH, cosine. So the function I'm choosing is cosine. The angle, the perspective is 47, equals adjacent over hypotenuse. Well, this is a little different. Now my x is on the bottom. No problem. Okay? I'll show you the algebra that's behind this, but then I'll show you the shortcut. Okay? The algebra says the way to solve this is multiply both sides by x and then divide both sides by cos 47. In reality, when we do problems like this, we don't do both steps because they're very simple. We just realize that both steps exist, and I can, when the x is in the denominator, just swap those two. Because that's the result of multiplying both sides by x and dividing by cos 14, or cos 47 in this case. Okay? So my answer is x equals 13 divided by cos 47. And same thing, I don't want to do cos 47 divided by 13. I want to do 13 divided by cos 47 in my calculator. So do that. 13 divided by cos 47. 19.1. And we've solved our unknown side. Okay?
Wait, how do you know if it's tan, cos, or...
We know it's tan, cos, or sine by knowing here the sides involved in this were the adjacent side and the hypotenuse. So by labeling our sides, we figure out which sides are involved in this particular problem. The opposite side is not involved. Okay, there's no variables there, there's no constants there, we're not interested in it. We're just interested in those two. So which function of sine, cosine, or tangent uses the adjacent or the hypotenuse? Well, sine uses opposite. Oh, opposite's not involved, sine is out. Cosine uses adjacent, hypotenuse. Adjacent, okay, so cosine's my choice. Okay? And look at, that's why we started yesterday with identifying sides, identifying perspective, the whole bit, because that is what helps us. SOHCAHTOA then helps us decide which function to use. To pick by knowing which sides are involved in this particular problem. Now, you might run into some eventually where all three sides are involved and you just have to pick two at a time. And say, okay, I'm going to forget about the opposite now, I'm just going to work with the adjacent hypotenuse, so I'm going to use cosine. Okay? Or you might use what I call a shotgun approach and set up all three equations in some cases. Try to hit everything. All right, let's do another one. Let's set another one up. Okay? Again, how do we do it? We start by identifying our perspective, always. So we know how to label the sides. We won't know if it's sine, cosine, or tangent yet. We just have to pick our perspective. Our perspective is right here. Okay? So that's our perspective. There's where our little stick figure goes. I want to find xc. So I want to find that, now x is a variable, so I'm going to call it n, so I don't get confused with the x as a point. If x is a point, don't use x as a variable, use a different one. Okay? So 53, if this is my perspective, what side is the n? That's the opposite side. The hypotenuse is right here, and this is the adjacent. Okay, so across top of my page, I'm still going to have written SOHCAHTOA. All right? So which sides are involved in this problem? Okay? Now I have the opposite involved and the adjacent involved. Which of my functions uses opposite and adjacent? Sine uses opposite, oh, and hypotenuse, so no. Cosine is adjacent, good. Hypotenuse, nope. Tangent is the tangent. So I'm going to pick tangent. Okay? So tangent is the function. What's my perspective? Tangent of, got to have an angle there. 53. If I could write it in the correct order, that would be even more helpful. So 35. Equals. Okay? Now, we know that's a decimal. We know tangent 53 is a decimal, but we want the decimal and the ratio in the same equation. What's the ratio for tangent of 53 in this triangle? N over 42. And now we just do our algebra. Everything's all set up. N's in the top, so I can just multiply both sides by 42. Remember, I'm not multiplying the 53 by 42. I'm multiplying the tangent of 53 by 42. So I go 42 tan 53 is 55.7. One more example. Let's try one more time. I want to find BV, which is right here. So I'll call it X, not N, because N's in the triangle. So, again, start by doing what? Perspective, because perspective is going to tell me the names of the sides. The given angle is the perspective. Name the sides. X is the opposite. The hypotenuse is right there. So this is the adjacent. Which sides are involved in this particular problem? opposite, and hypotenuse. Which function involves opposite and hypotenuse? Sine. Okay? So sine of my angle equals opposite over hypotenuse. And your work is done. Now the rest is in your calculator. 15 sine 33, 8.2. Okay? So what am I going to be looking for in the homework? I'm going to definitely be looking for this equation for every problem. Okay? I need to see that equation. I'd like to see you indicating your perspective and naming the sides. Now, some people decide to write OAH for their sides. That's fine. Okay? But I need to see the equation and then the solution. If all I see are the solutions, that doesn't help me very much. I want the equation and the solution. Okay? And that's what we got for today. Where's the stop recording? Oh, here?